Nanotechnology is a field of research and innovation concerned with building things, generally materials and devices. And the most important part, most interesting part of this, building things at the scale of atoms and molecules. Yes, at the scale of atoms and molecules. We are talking about the basic development. Nanotechnology gives us the strength to develop materials atom to atom. Something that created by God, something that developed by nature, in plants and animals, in human beings. Yes, nanotechnology gives you the power. A nanometer means a 1/1000th of a meter. Basically, it's at 10 times the diameter of hydrogen atom. If we talk about the thinnest example of any thinnest thing, then one can tell human hair. The human hair is about 80,000 nanometers. So you can take about 80,000 magnitude of 1 nano. At this scale, why the nanomaterial is so much important? Why all the websites, all the newspapers are flooded with this? At this scale, ordinary rules of physics and chemistry no longer apply. Yes, that is the interesting part of nanotechnology. If you are working with nanotechnology, you have to search new kind of physics, new kind of chemistry. Your concept of color, your concept of strength, your concept of conductivity, reactivity, everything will change with this. As a matter of fact, you can say everything will change substantially when you move from micro to nano. Just to give an idea, that carbon nanotubes are 100 times stronger than steel, but on other side 6 times lighter. Can you imagine? Now you will have very strong material with very light properties. The material is light, weightless, but strong. Yes, this is the basic strength, basic attraction with the nanotechnology. In this lecture, in this first lecture of our chapter, our paper, our course, we will discuss about emergence of nanotechnology. Nanotechnology is emerging, still emerging. But the real sense, first, before learning to nanotechnology, we must go through with these years, with the history, from where this word came first in picture. We will discuss various citations, various examples from where it began in this lecture. After this lecture, we will also talk about many other properties and synthesis and characterization and so many things. But the first thing is emergence. in this lecture, we will learn about what is nano. We will define nanotechnology, nanoscience, then why it is so important, why we are talking about this, what is the potential of this nanotechnology, how we can justify it with interdisciplinary science, interdisciplinary technologies. Then we will discuss who first coined this word, from where you can say nano era begins officially or in a systematic way. Who are the main founders? We will discuss about creation of engine, we will discuss about Feynman, and then how application developed. Discussion about first application we will discuss in this first lecture. Nanotechnology, as defined by size, is naturally very broad. This includes fields of sciences. The arena is as much wide diverse as it starts from surface science, then organic chemistry, molecular biology, semiconductor physics, energy storage, microfabrication, molecular engineering, and so on. The associated research and applications are equally diverse, ranging from extension of conventional devices, from physics to completely new approaches based on molecular self-assembly. Words are very fancy. Self-assembly. Yes, assembled by their own way, by their own forces, we will discuss here. This includes development of new materials with dimension on the nanoscale to direct control of matter on atomic scale. As we have discussed in the last slide, here are some examples. The scale that is shown here, 0.1 nanometer to 1 millimeter. And many things are shown here. You can talk about atom, which is about 0.1 nanometer, then fullerene, about 1, then DNA, then if you move to further, then you move to 1 micron blood cells, or many other things. So, whenever we are talking about nano, we are talking about bottom of the devices, bottom of the synthesis. What happened at the first atom or the first group of atoms? So that is important here. Whatever we saw, whatever we use, it has been started from the first atom. And this technology gives you the power, the wisdom, even to manipulate single atom. That is the best part of this technology. The history of nanotechnology actually traces the development of concept and experimental work, falling under the broad category of nanotechnology. As we have discussed in the last slide, nanotechnology itself is not a subject. It's an umbrella. It's a canvas on which all the sciences may merge to develop. Sciences like physics, chemistry, biology, mathematics, computer science, all joined here. So whenever we talk about history of nanotechnology, we are talking about history of science, history of engineering and technology. Many things have been developed. Soon I will show you. On one side, we can say the history of nanotechnology starts from 1954 or 56. But we know the nano word, nanotechnology, is already being used in the ancient centuries. We will take some examples from also from there. But the important thing is, first, what is that and how this nanotechnology developed. Can you see the different colors bottle here? Yes, the colors are very attractive. And why? The colors are attractive, and I am saying the colors are of the same element. Surprising? Yes. The nanotechnology showed us even the same material of different size may give you different colors. Color is not the property of material. Color is the property associated with the size of the material. When we move below 100 nanometer, everything will change. We can analyze the things. These unique phenomena enable novel applications, which is not possible whenever we are working only with bulk materials. Amongst all technologies, recent technologies, nanotechnologies are amongst the great technological advance of recent time. Yes, it has huge potential to develop. It has wide spectrum to develop. It has huge potential in interdisciplinary research. Nanotechnology is not an industry, nor it is a single technology or a single field of research. We call nanotechnology consists of set of enabling technologies which are applicable to many traditional industries, which have huge potential to develop to cater many agency industrial implications. I suggest we must understand the emergence of nanotechnology, from where this word came, how we have developed, and what is the future of this. Here this is shown and how physics, chemistry, biology all merged here. In the physics, we started with electronics, electron technologies, then microelectronics, then material design we moved, and after material design we improved the designing of materials. Small size, which all of you are aware of the small size electron devices. Then we started the searching of quantum effects and moved to electronic devices at nano level. On other side, we are studying a lot in biology, studying a lot in cell biology, molecular biology, and from there we started the searching functional design of molecules, designing of proteins, carbohydrates in the lab. On the third side, chemistry is also developing. We have worked a lot on complex chemistry and supramolecular chemistry. For development of device, chemistry helps a lot. That is why they merged together. Biology entered in this region to improve the sustainability of the devices, flexibility in the system. And that is why now our approach is integrated. We are exploiting many principles, many laws, many properties in an integrated way. Although nanotechnology is a relatively recent development in scientific research, the development of its central concept happened over a long period of time. It does not begin here in few days or few months. It took a long time to develop. However, we can say it has started from something in the second half of the 20th century, and then the interest increased in the last 20 years and from 1980. But we have many examples from the ancient past on this. There is plenty of room at the bottom. An invitation to enter a new field of physics. This was the title of one of the most celebrity lecture by physicist Richard Feynman. This lecture was given by Feynman in December 29, 1959. Yes, the evening of December 29, Caltech University witnessed one of the greatest lectures of this era. There is plenty of room at the bottom. In this lecture, Feynman considered the possibility of direct manipulation of individual atoms as a more powerful form of synthetic chemistry than those used at the time. Feynman was the person who thought about manipulation of atoms, manipulation of matter at atomic scale. He was particularly interested in possibilities of denser computer circuitry, microscopes that could see much smaller than the possible. And you can Imagine how visionary the person was, that these things were developed after 1980. In this 59 lecture, he suggested that it should be possible in principle to make nanoscale machines that arrange the atom the way we want and do chemical synthesis by mechanical manipulations. That is very interesting thing. He talked about manipulation of atoms and the microscopy in this lecture. And this dream came true after 1980. Although the version of the talk were reprinted in a few popular magazines, it went largely unnoticed and didn't inspire the conceptual bringing of the field. Now, beginning in the 1980s, nanotechnology advocates cited it to establish the scientific credibility of their work. You must realize this. Up to 1980, nobody will give much credit to this lecture. Feynman also suggested that it should be possible in principle to make nanoscale machines that arrange the atom that we want and do chemical synthesis by mechanical manipulation. He also presented a theory, swallowing the doctor. It means if you are not feeling well, now the doctor will not inspect you. You can swallow the doctor. The idea that he created the essay to his friend and graduate student, Albert Hicks. The concept involved building a tiny soluble surgical robot. These visionary ideas he has given in 1954. But then, for the next 25 years, nobody bothered. But at the beginning of 1980, people working on this. People started talking on this. The concept that he noted, when you reduce the size or when you work with small particles in that physical phenomena, the gravity would become less important. And the most important forces will be surface tension and van der Waals attraction. And this will play a very important role. All of you are aware with this. Gravity depends on mass. For atoms, these forces are very strong, surface tension and van der Waals. In the coming lectures, we will discuss these effects, surface and van der Waals, in detail. Maria Taniguchi, a Japanese scientist from Tokyo University of Science, was first to use this term, nanotechnology. He used this term in 1974 conference to describe a semiconductor process such as thin film deposition and ion beam milling, exhibiting characteristic control on order of nanometer. thin film deposition is again something very important was happening at that time after the invention of transistors and development of electronics, semiconductor electronics. He used this term to study the characteristic control of the order of nanometers. According to Norio, the nanotechnology mainly consists of processing of separation, consolidation, and deformation of materials by one atom or more molecules. This was another name big in the field of another biggest contributor of the initial nanotechnology was Drexler. He developed and popularized the concept of nanotechnology and founded the field of molecular nanotechnology. Yes, the field of molecular nanotechnology is the beginner of this, founder of this technology. In 1980s, he took this idea, the idea which was given by Feynman, and he explored this idea in depth, promoted the technological significance of nanoscale phenomena and devices. He worked too much on delivering speeches, and he had given two influential books. In 1980, he prepared a book, a scientific paper, Molecular Engineering, an approach to the development of general capabilities for molecular manipulation, which is published in Proceedings of National Academy of Science in 1981. He used the word nanotechnology again in Engines of Creation, which is one of the big celebrity books by Drexler in 1986. Engine of Creation, the common era of nanotechnology, proposed the idea of a nanoscale assembler which could be able to build a copy of itself and other items of arbitrary complexity. He also used a special term, grey goo, to describe what might happen if a hypothetical self-replicating machine capable of independent operation were constructed and released. Drexler's vision of nanotechnology is often called molecular nanotechnology or molecular manufacturing. These are the three who developed nanotechnology. Apart from the development of theory, 1980s known for invention of STM. The dream that come true in the 1980s, which were developed or first thought by Feynman 1959. The invention of scanning tunneling microscope in 1980 by IBM Zurich scientists and then the AFM atomic pore microscope allowed scientists to see materials at an unprecedented atomic level. The availability of more and more powerful computers around this time enabled large-scale simulation of material systems using superconductor computers. These studies provided insight into nanoscale materials, structural and their properties. The complementary activities of modeling and simulation, scale visualization, and characterization and experimental synthesis activities fueled nano research activities in 1980s. Yes, this is the time when people started working on nanotechnology. In this lecture, we have discussed about introduction to nanotechnology, the main collaborator who started this subject, and brief about how emergency this nanotechnology emerged. In the next lecture, we will discuss how this emergence intensified and many other works have been developed. Thank you.